Assalamualaikum warahmatullahi wabarakatuh, and hi to all of you. So in this video we will discuss the last non-continuous function, which is a periodic function. Okay, by definition, okay, a periodic function, okay, a function is said to be a periodic function if, okay, it meet this condition where you have ft equal to ft plus capital T. Okay, where T, capital T, is the period of the function. Okay, if you look over here, this is a well-known periodic function. I think you should know this. This is a sine function. Okay, so we have sine function over here. Okay, as you understand that if we have one cycle, okay, which is this one cycle, which is this is a periodic function, this is the periodic where the distance for one function, okay, where time distance of one function or one cycle. And then for periodic signal, the characteristic is that, okay, it has a repetitive pattern. Okay, this is the first pattern. Okay, and then for the next cycle, okay, the pattern will be repeated, and then after that, the next cycle, it will be repeated again, and then this will be repeated over and over again until infinity. So this repetitive pattern, okay, is one characteristic of a periodic function. Then the repetitive pattern will be repeated over a period of t over here. Okay, so this is sinusoidal signal. Okay, another example of a periodic function, okay, which is this one, and then it repeated over and over again, okay, with the periodicity of equal to t over here. Okay, the periodicity is equal to t. So when you have over here, so you know that, okay, for a periodic function, if you have ft, this will be equal to, if you take one cycle over here, which is ft, and then if you have ft plus t, which is this one is shifting by t, so this pattern will be shifted by t. Okay, so it will be carbon copy of this pattern. Okay, with this it will be the same, and then repeated over and over again. So that's the reason why you have ft equal to ft plus t, capital T. Okay, which is you have this one cycle, and then this one cycle move to here. Okay, okay, move to the right, okay, for one period, so you will have a carbon copy of this signal, okay, or this function. Okay, so that's the reason why for periodic function, the condition is equal to ft equal to ft plus capital T, which is capital T referring to the periodic of the function. Okay, so we have over here to find a Laplace transform for a periodic function. So now we have Laplace transform for ft. Okay, ft is a periodic function, and then if ft is periodic function, Laplace transform for this function, okay, can be found using this theorem, which is equal to 1 over 1 minus exponent negative s capital T, and then we will integrate over 0 to capital T, okay, which is this periodicity, exponent negative st ft dt. Okay, this is our function for one cycle. Okay, so let's do an example. Okay, so this is example example 4.26 in your book, in page 134, and then we will do the first question, which is question A. Okay, where we need to sketch the graph for the function, which is this function, and then after that we need to find Laplace transform. Okay, so if you have over here ft is equal to exponent negative t, t from 0 to 1, and then ft equal to ft plus 1, meaning that this is a periodic function, which is we will have repetitive pattern of exponent negative t. Okay, the first task we need to do is that we need to sketch the graph for the signal, right? So let's do it. Okay, so to draw graph of the signal, okay, so we will have, remember, a repetitive pattern. So we need to do the first pattern and then we will repeat the pattern over a period of capital T. So we have over here, okay, first we need to draw the signal. Okay, so this is our function, which is ft, and then we have value from 0 to 1, which is exponent negative t. Okay, so for exponent negative t, when t equal to 0, so you will have equal to 1. And then you need to draw the first graph, which is from 0 to 1, which is exponent negative t, decaying exponential. So we have over here, okay, this is the first cycle. Okay, so we have over here ft plus 1, meaning that this is a periodic function, and then we will repeat this pattern, okay, to the next cycle, which is from 1 to 2 over here, and then we will copy it, or we will repeat the same pattern. Okay, so same goes to the next cycle, which is from 2 to 3 over here. So we will have the same pattern. And then for 4, t equal to 4, same thing, it will repeat the same pattern. And then it goes on until infinity. So this is a graph for our function, okay, which is function ft. Okay, the next one is that we will need to find its Laplace transform, okay, by using theorem Laplace transform for periodic function. Okay, so if you want to find Laplace transform for this one, for ft, and then you need to remember that ft is a periodic function. If it's not periodic function, you cannot use this theorem. So you must make sure that ft is a periodic function, where you will look into this condition, okay, which is you need to look into this condition. Okay, so you have Laplace transform for a periodic function ft. This will be equal to 1 over 1 minus exponent negative s. And then we will integrate this from 0 to t, and then exponent negative st ft dt. Okay, so where ft is the function, and then we will integrate over one period. Okay, and then multiply with 1 over 1 minus exponent negative s. Okay, let's continue the calculation. So we have over here 1 over, this one is t, don't forget. So we have 1 minus exponent negative s, and then t is equal to 1. For this case, this is our t, which is 0 to 1, and then t is equal to 1. So we have there t equal to 1, so we have exponent negative s, and then the integration is from 0 to 1, exponent negative st, and then ft is exponent negative t, okay, which is coming from here. So we have over here exponent negative t dt. Okay, the next one is we can do factorize this. So we have 1 over minus exponent negative s, we just write it down. So we have integration from 0 to 1, exponent negative s plus 1 t. Okay, and then we will integrate over dt. Okay, so we have over here 1 over 1 minus exponent negative s, and then the integration, okay, for this one will be equal to exponent negative s plus 1 t, and then we will divide this over negative s plus 1. Okay, where we will find the value from 0 to 1. Okay, so this will be equal to 1 over 1 minus exponent negative s, and then this will be equal to exponent negative, okay, s plus 1, and then this will be multiplied with 1, and then divided by negative s plus 1. Okay, and then will be minus. Okay, so exponent negative s plus 1, and then t is equal to 0, so meaning that this will be equal to 0, so you have 1 over negative s plus 1. Okay, so this will be equal to 1 over 1 minus exponent negative s. Okay, we have exponent negative s plus 1, and then divided by, okay, negative s plus 1, and then negative and negative will become positive. You have positive 1 over, okay, s plus 1, because this one negative and negative you multiplied already, so we don't have negative over here. And then this one, okay, we can change. Okay, negative go up. Okay, so this will be equal to, okay, so this will be equal to, okay, this actually Laplace transform for ft is our fs. So we have over here, okay, fs, okay, continuation from this one, so you have 1 over 1 minus exponent negative s, and then we have now this one negative, so that we can make it the denominator equal. So we need to move negative to the top, so you have exponent negative s plus 1, and then divided by s plus 1, and then add, okay, 1 over s plus 1, right? So this will be equal to 1 over 1 minus exponent negative s. And then now we have the same numerator, so we can make it s plus 1, and then 1 exponent negative s plus 1, and then plus 1 over here. So you can write this way, 1 minus exponent negative s plus 1. Okay, so this the one. Okay, this is the value. Okay, the next one is, so we can have over here, okay, 1 minus exponent negative s plus 1, and then you will multiply this together. So we have 1 minus exponent negative s, and then multiply with s plus 1. Okay, so this is the Laplace transform for our signal. Okay, so hopefully you understand, okay, what is a predict function, okay, which is this one. What is a predict function? Okay, by definition, predict function is ft equal to ft plus capital T. So a predict function must meet this condition. Okay, where T over here referring to the period of the function. Okay, as the main characteristic of a predict function is the graph is repeated over and over again. Okay, so until infinity. So that's the reason why definition ft equal to ft plus t, where t is referring to the predict function. Okay, in terms of if you want to find Laplace transform of predict function, we can just use this theorem. Okay, so this will be, the Laplace transform will be equal to 1 over 1 minus exponent negative s capital T, and then we will integrate over t, which is from 0 to t, exponent negative st. Ft is our signal, and then we will integrate over dt. Okay, where you must make sure that s value is more than 0. Right, so that's all. Okay, alright, hopefully you understand it, and then thank you for watching, and then see you again in the next video. Okay, bye.